Hi, this is Bill Punch at Michigan State University. Another video in the series of videos, The Practice of Computing Using Python CSE 231. We're going to continue our series on classes, and this time we're going to look at how to create our own methods and the special variable self. Let's get started. So let's go back to our famous point class here. Here it is again. And here's another image to sort of point out some interesting things about this. So before we pointed out the fact that there are methods and the class definition name, but I want to point out this special variable called self. And I want to point it out in two different ways. In green, you'll notice that the first parameter for every one of these methods is self. We need to talk about what that variable is, and then secondly, inside of these methods there are lots of references to the variable self. And so first variable in every parameter list, and then used extensively inside the methods themselves. And what we want to say is that it is true that the variable called self is always the first parameter. Now it turns out you can call it anything you want. So the first parameter is special. You can call it whatever you would like to call it, but every real programmer gives it the name self. And what we want to remember is what happens when we do a dot call, and here again is a picture that I think makes things easier. When we create a point instance by calling the constructor, and then we use a dot call, so this instance dot a particular method name 2 and 3, the way this gets translated to our point class is that the instance that does the call is always bound to that first parameter self, and then subsequently the second and third parameters are also bound. So what's special about self is that whoever we called in the dot call, whatever instance was done with the calling, is going to be bound to self. And in that way, when we talk about doing, say, the translate method, we talk about applying the translate method to a particular instance. We can apply it to many instances because every time we do the call, the name, or rather the value of the particular instance, is going to be bound to that special variable self. So here we are doing it again. We make a point. We call the print point method, right? And if we look at the print point method, and here it is up here, we'll notice that not only is self bound, so it's the instance that called us, but then inside of the method we're talking about the x coordinate of self, right? The y coordinate of self, so that when we do a printing, we're talking about printing the values internal to this instance, the one bound itself, to this instance, the one bound itself, so that when we get the results back, we're printing the point, right, the values for that particular instance. And so self gets used as the first parameter, and then everywhere where we need to talk about things to do with the instance that called it, we use self.this, self.that. Python also has some special names. We've seen these before. Those are the names that begin and end with this double underline. Python reserves names with these two underlines in front and back of the method when it has particular uses for them. The one that we want to talk about today is the double underline init double underline, this guy. And we've seen him in our point class all the way along, but we want to talk a little bit about what that means. Again, we have a picture. Let's take a look. We said that when we create an instance, when we create a class, whatever the class is, so apparently there's a class called myClass, automatically created for us is a constructor of the same name. This is how it goes. I call the constructor. Python does its instance construction stuff, and there's standard stuff available to do that, and it almost finishes, and it asks a question. Is there this specially named method associated with that class? If it's not, then what Python returns is a default instance. And so we'll get an instance no matter what. However, if such a method is available, then what it will say is, I'm going to bind self to that default instance, and I'm going to call that particular method, the double underline init double underline, so that we, as people who wrote this class, can do special initialization. Let's go back and look at our point class. Here, then, let's talk about the init process. So there is a double underline in it, double underline in the point object, right? Self would get bound to the default instance as it gets made. These are other parameters that we could provide. And then what do? We say, in that default instance, we're now going to add a data attribute called x underline coord, and we're going to set it to be equal to the parameter x. We're going to say the self dot the default instance is now going to have a data attribute y double underline coord and set it to the value of y. So we're going to change the default instance to have stuff that's associated with our instances of our class, and that's where we do it in the init. There are different ways to do it. So we can call, because the way we set this up, we gave them default values. We can say call the point constructor, take no values, and they'll be set to 0 and 0. Call it with y set to 100 and x will be set to 0. Call it with y and x set to 50, and we can print those guys out. And it turns out that at the end, if we look at these instances, they will all have contained within them the values that we wanted, the x coord stuff. If I print a directory of the instance P0, you will see that it does have x coord and y coord provided to it. So we can call methods, and not only can we call methods, we can call one of the methods that creates instances so that we can get the value that we're looking for. Lastly, because Python puts the initializer in a pipeline of the construction process, which we've shown up here, right? So the initializer is part of an overall construction process. It turns out that you cannot have a return in an initializer. Right? Python takes care of the manipulation of the default instance, and so if you look at the initializer code, you do not have a return value in there, and it will be illegal to do so.